One of the main challenges when searching for alien life is that we still have very little idea as to how they will communicate. But, fortunately, searching for ET messages isn't our only option. Researchers are increasingly saying that we should target alien planets first of all before seeking out the aliens themselves. And fueled by modern technology, we could be on the brink of a major breakthrough. The search for alien life in the universe is an ever more serious topic of astronomical study. The chief organization leading the charge is SETI, or the Search for Extraterrestrial Intelligence. SETI is the leading large-scale group in America that solely searches for alien life in the universe, doing so with a variety of telescopes. However, much of SETI's search still relies on radio telescope technology, on attempting to recognize radio signals in space as either natural phenomenon or artificial alien-made broadcasts. This, though, perhaps isn't a surefire way to find intelligent life. There's always the chance that an alien force wouldn't send messages via radio, for starters, or that we would be unable to recognize a message if we actually ever received one. The best example is probably the famous WOW signal. Received back in 1977, it seemingly had all the signs of being created by an intelligent species. But more than 45 years later, and we're still not sure if that's the case or not. We only heard the WOW signal once and have never managed to get another sample. Was it alien life or just a natural process in space? No one knows, because radio messages remain so ambiguous to us. Might it then be high time for a change of strategy? Many scientists want to now find more definitive markers of alien power, and especially visible signs. Technosignatures are exactly as they sound, characteristics or effects detectable on a planet, moon, or cosmological object that explicitly points to the presence of technology and therefore intelligent life. As such, some argue that radio signals shouldn't be included under this classification, that they shouldn't be considered a true technosignature, because they leave so much room for uncertainty. Examples of firmer, much less debatable technosignatures are generally large-scale megastructures that are big enough to be seen from across space. Hypothetical concepts like Dyson spheres, a massive machine to harvest energy from a star, or Shkadov thrusters, which are giant devices that can move stars and are known as stellar engines. These would all be certain signs of civilization. Technosignatures have an advantage over biosignatures too, or signature effects created by biological life, because technology can outlive biology. Studies have suggested then that technosignatures could be more common in the universe, and also that they should be easier to see, should last longer, and should be easier to understand than possible biological traces. This means that even were an alien group to go extinct, there's a chance that we could still discover them by spotting one of their technostructures hundreds or thousands of years later, long after their biological imprint has disappeared. If we view the universe searching for machines rather than straight-up life, then the chances dramatically increase that we will find evidence that we really are not alone. Published in the journal Acta Astronautica, a new study by lead author Jacob Huck-Misra and an international team of scientists was written as the result of a NASA workshop, and it argues that we already have the tools to start studying technosignatures in depth. It's just that generally we don't seem to be using them. One reason for this is cost. Funding can be difficult to obtain for studying non-radio technosignatures, perhaps because they're sometimes so far beyond human imagination. However, Huck-Misra and his team argue that grant funding isn't necessarily needed, as most space missions that are already underway could be adapted to specifically look for technosignatures at no extra cost. That beyond human imagination aspect, though, is another problem. Even our brightest scientists don't really have a solid understanding of which signatures could be artificial and which could be natural. In both cases, we're largely guessing as to the machines or life forms that could be making them. So there remains a big gap in our knowledge, creating a similar level of ambiguity as seen with radio waves. One solution to the current hesitancy would be for the astronomical community to come together to catalog and understand the various types of technosignatures that we might expect an intelligent civilization to produce. If we had a library of possible signatures, then we'd have a much surer base to work from, and could apply that library to every single exoplanet we come across. But unfortunately, no such grand project exists. There are private enterprises like Breakthrough Listen, and there's some interest from within SETI, although radio waves remain most studied. But at present, we're at something of a dead end. A valid technosignature could be our best bet to find alien life, but we're still hedging our bets with radio and largely neglecting the search for technology. Undeterred, however, Huck Misra's study provides specific examples of the technological signatures we should be looking for. Using different observational mediums such as ultraviolet, visible, and infrared radiation, astronomers can search for a wide variety of markers like waste heat, energy-intensive illumination, surface modifications, atmospheric pollution, stellar pollution, non-terrestrial artifacts, and megastructures. One sign of technology, for example, could be present in a planet's atmosphere. The paper suggests that by examining the atmospheric content for artificial molecules like sulfur hexafluoride, or by looking for expected signs of life like oxygen or methane, we could clearly identify the worlds that are the best candidates for life. Of particular interest here is nitrogen dioxide, because while it can occur naturally on Earth, human technology produces exponentially more of it through the burning of fuel. Should NO2 turn up when we look at another world then, there could be a good chance of some similarly industrial, intelligent creatures living there. As bizarre and seemingly straightforward as it sounds, there are also calls within the study for astronomers to look more pointedly for cities just as optical light. For massive city structures that could shine brightly enough on their home planet so as to be picked up by simply watching for long enough. It's thought that aliens more advanced than us might have built what's known as an ecumenopolis. This is a city so advanced and vast that it covers the entire surface of a planet. And the immense light that such a structure would generate should clearly shine out across the distances of space, not unlike stars do. And then, against the potential backdrop of an ecumenopolis, researchers might also try to pick out artificial satellites as the next greatest sign that life is present. There are even some proposals that the movement of satellites could double up as a method of cross-cosmological ET communication, too. Again, for those pushing for a greater emphasis on technosignature hunting, the beauty is that all of these examples can be searched for in the data we already have. And current and future telescopes can add in technosignature searches at no extra cost as well. According to those behind this latest study, current telescopes or current databanks that are already fit for purpose include the Kepler Space Telescope, the Transmitting Exoplanet Survey Satellite, TESS, the Gaia spacecraft, the James Webb Space Telescope, and more. With Webb, we've already seen the incredible detail our telescopes can now produce with the atmosphere composition study of WASP-96b, an exoplanet that's 1,100 light-years away. It's perhaps surprising then that there hasn't yet been a significant search made for technosignatures. More than 5,000 exoplanets have now been cataloged, but they've yet to be thoroughly scoured for tech signals. It's the hope of Jacob Huck Misra, his team, and a growing number of other scientists that this will soon change. And there is reason to think that it will. The first ever NASA grant, given specifically for the study of technosignatures, was awarded in 2020 to the astronomer Adam Frank. There are calls to add machine learning processes into our study of the moons and planets that we do know about too, to increase speed and efficiency into the future. And so, the push towards this new way of thinking is gathering pace. Of course, all of this raises further interesting questions. Could we have already spotted an alien world without realizing it? Might we have already viewed alien life just without understanding what we were seeing? Our 5,000 confirmed planets is certainly only a small window relative to the rest of the universe. But could one of those worlds be home to something else? Very, very possibly. NASA, the National Aeronautics and Space Administration, has long led the line for space research, delivering various iconic moments since its inception in 1958. But today, partway through the 21st century, the landscape has dramatically changed. Where once NASA was out on its own, with only the Soviet space program for company, now there is a raft of major competitors in the field. To stay ahead of the game then, NASA will need to pull out all the stops. First up, long-distance astronauts. You might reasonably argue that any astronaut capable of reaching the moon is or already has been suitably long distance in themselves. But again, times have changed, and getting to the moon is now relatively small fry in the minds of today's future planners. Instead, with all eyes on a proposed mission to Mars, around 140 million miles away, we need a new breed of astronaut, capable of not only a few days cooped up inside a spaceship, but a few months, and probably more than a year away from Earth for an entire return mission. NASA is on it though, with its Crew Health and Performance Exploration Analog and Mars Dune Alpha facility, a simulated Martian habitat. Located at the Johnson Space Center in Texas, Mars Dune Alpha is designed to mimic what life would be like on the Red Planet. And in summer of 2023, it'll get its first proper use, when 4 volunteers start a year-long experiment of living inside it. For those 4, life will become a daily test, as they'll take on tasks such as simulated spacewalks and the growing of crops, all while discovering how easy or not it is to maintain the environment itself, plus their own personal hygiene and mental and physical health. Experiment runners will also trigger instances such as deliberate equipment failures to test how well problems like these can be solved. Even if we never actually get to Mars then, we should soon at least have a band of people capable of surviving the trip. Of course, and even if it is perhaps less remarkable than it once was, before Mars comes the moon. And here, NASA is increasingly confident of making major progress in just the next few years. The Artemis program is the agency's flagship project right now, promising to return astronauts to the lunar surface, and this time to stay there. While we haven't actually been to the moon in person since Apollo 17 in 1972, the plan is for Artemis to kickstart a new era of the U.S. having a constant presence on our lunar neighbor, with perhaps months-long shifts for the astronauts up there, as we currently do on the International Space Station. What's arguably more exciting, however, is the Lunar Gateway, which NASA describes as a, quote, vital component of the Artemis program. When complete, it will cruise through the skies around the moon, orbiting at an optimum distance to 1, provide around-the-clock support to any moon-based astronauts at the time, and 2, to serve as a key outpost and potential launch location for other missions into the solar system and deep space. In some ways like the ISS, only circling the moon instead of Earth, building the Lunar Gateway is set to start in 2024, with a proposed finish date of 2031, although many believe it will be later. Our moon isn't the only moon out there, though. And in fact, it probably isn't even the most interesting moon in the eyes of most at NASA. One of the key challenges facing the next generation of NASA scientists is how to explore in detail all of the other moons in the solar system, but most notably Jupiter's Europa and Saturn's Titan. Of all the other worlds that are relatively nearby in the grand scheme of the universe, these are the ones that appear most habitable to us and perhaps to alien life as well. And over the coming years, you can well expect missions to them to be making the headlines. For example, the Europa Clipper mission is one of the latest initiatives, reportedly set to launch in 2024. It'll be beelining straight to Jupiter, following the collapse of a previously planned NASA mission to the Jovian system, but will be targeting repeated flybys of Europa in particular. Meanwhile, and although Saturn missions have historically lagged behind Jupiter projects with NASA, that could all change with the Dragonfly spacecraft, scheduled to launch in 2027, planned as it is to soft land on Titan for an unprecedented up-close look at this distant world. Dragonfly could well become one of the most important bits of kit that NASA ever produces, especially if it finds life where it's headed. That's all well and good, you might say, but we're still confined to just our own solar system, in a galaxy full of others like it, and a universe full of countless more galaxies too. But while it is unlikely in anyone's lifetime that NASA will advance enough to begin sending targeted probes to other cosmological structures entirely, there is hope in abundance that the agency will break new ground with propulsion methods, and there are multiple directions down which it could head. For example, in January 2023, NASA announced that it and DARPA, the Defense Advanced Research Projects Agency, will work together to test a nuclear thermal rocket engine in space. According to NASA, this particular enterprise could be a key moment in its Moon to Mars push, as it should easily enable longer period space travel. NASA explains that if the rocket works, inside it there will be a nuclear fission reactor, which will heat a liquid propellant to incredible temperatures for a setup that, quote, can be 3 or more times more efficient than conventional chemical propulsion. It's an effort that falls under the wider Draco propulsion program at NASA. And although it remains a way away from breaking out of the solar system proper just yet, it appears to be a case of watch this space. And it looks a solid bet that we will see some major and fundamental propulsion upgrades over the next generation. We should remember, though, that not everything NASA does is spacebound, and perhaps its greatest imminent impact in our own skies will be to do with supersonic flights. Anyone who remembers the Concorde knows that this actually isn't new technology. Not exactly. And particularly because we have many military jets today that are capable of breaking the sound barrier. However, NASA wants to make supersonic travel more practical than it's ever been before by removing the sonic boom. Most of the contemporary interest surrounds the Lockheed Martin X-59 Quest aircraft, with Quest standing for Quiet Supersonic Technology. The characteristically deafening thunderclap that's usually generated is why at present flight guidelines in the US prohibit supersonic travel over almost all land. The noise associated with the shockwaves that are made is just too much. However, the X-59 Quest is scheduled to begin test flights in 2023, with those behind it hoping that it could be good to go by the end of the 2020s. And with NASA partnering with Lockheed for this particular venture, there are already hopes that the currently single-seater plane will one day be expanded into a larger commercial vehicle. But finally, and if there's one message to link almost all of these future NASA plans, it's that there's beauty in the detail. Over the years, the agency has pushed and pushed the boundaries of human knowledge, so that now we have a very solid base understanding. The next challenge, then, is to refine that understanding by returning to the places we've been before, but better prepared, by obtaining clearer imagery and samples of even the most far-off worlds, and by tweaking current technology to make it even better and properly fit for purpose. This isn't one single breakthrough in itself, but more like a new era expectation held by those within NASA and by everyone else watching on. Perhaps the James Webb Space Telescope is the greatest current example. It is now producing an endless stream of incredible visuals, so much so that for the casual onlooker, it might feel as though one intricately captured supernova is the same as the next, as the next, as the next. But that will never truly be the case. And in a universe crammed with infinite possibilities, NASA is leading the charge to make it as accessible as possible. If there's one thing that seems certain to unfold over the next generation or two, it's that the unknowability of space will finally be lifted. Space will be painted not as an abyss, as it may have felt in past decades, but as an opportunity, as a blank canvas, as an inspiration for hope. And while it remains true that NASA is no longer out on its own, it is still a very major player in making that happen.
When humans first began exploring Earth and migrating to new locations, a complete map of the world, the like of which we have now, was still a far-off dream, let alone an instant, detailed picture of almost any place on the Earth, as we also have thanks to satellite technology. We're now at a similar early stage with the universe, however, and the prospect of plotting and mapping every planet out there feels impossible. But naturally, NASA is trying its best anyway. For most of our history, humans have only been aware of one planet in the universe, Earth. It feels strange to modern minds, but knowing that there are other worlds out there is still a relatively new sensation for us. It's only been over the last few thousand years that we've really gotten to grips with it, identifying the likes of Mercury, Venus, Mars, Jupiter, and Saturn some 4 millennia ago, before a long gap in which our astronomical technology and know-how improved, until our telescopes could finally pick out Uranus for the first time in 1781, Neptune in 1846, and the dwarf planet Pluto in 1930. But of course, today, we know that all those planets, dwarf planets, and their surrounding moons and other objects are all quite close to us, since they're in our own solar system. So, exoplanet discovery, Revealing planets in other star systems is an even more recent phenomenon. In 1992, the first two confirmed exoplanets, nicknamed Poltergeist and Phobiter, were found revolving around a pulsar. And ever since then, exoplanet discovery has grown and grown. It's not as simple as just pointing your telescope in the right region of the sky and then spotting one, however. Most of the time, astronomers don't even see the planet they identify at first. Instead, a variety of methods are used to predict the presence of a massive body nearby. For example, most exoplanets are discovered via something called a transit method. This is the technique of watching a usually much larger star to see if its intensity dims at all due to its light being obscured by an object in orbit around it. Based on how much light is covered, scientists can then calculate how massive that orbiting object is, and thereby determine whether it is or isn't a planet. Another technique used is called the radial velocity method, where astronomers again watch stars first and foremost to see if their light becomes red or blue shifted, presenting a kind of wobble, which could be the result of a nearby planet's gravitational influence. Further methods for exoplanet detection include direct imaging and gravitational microlensing, which we saw in a recent video was also used to detect perhaps the most distant star ever found. But back to planets, and although some are used more than others, all methods have their own advantages and can be used to verify the findings of another. Nowadays then, we have plenty of bases covered, and although all these techniques require super advanced telescopes, we have an ever-growing fleet of cutting-edge, specifically designed facilities, both on the ground and in space itself. Using all these instruments and methods, NASA reached a milestone in exoplanet discovery midway through 2022, when it officially added the 5,000th discovered world to its archive. To break it down, many of those 5,000 were found by the Kepler Space Telescope, an iconic design launched in 2009 for the express purpose of discovering planets that revolve around distant stars. Kepler spent an eventful 9.5 years in space and uncovered thousands of planets and thousands of more potential planets before it finally ran out of fuel in 2018. In many ways, its mission is a model for how the search for exoplanets has unfolded in general. Because although 5,000 have now been confirmed by NASA, there are still many more suspected discoveries that haven't been verified yet. The verification process is long and intensive, with any one potential planet having to be shown by at least 2 methods of observation. The findings must then be published in a peer-reviewed journal, which can often take years. The Transit Exoplanet Survey Satellite, or TESS for example, has so far confirmed the discovery of more than 200 planets, but it's discovered more than 20 times as many planet candidates that are currently under review. So, although 5,000 is the official total number only just passed, we know that thousands more have likely already been found. We're just waiting for them to be rubber-stamped. If there's one thing that astronomers have learned from cataloging all these other worlds, it's that there's a huge amount of diversity in the types of planets that form. NASA has a categorization system that tries to break exoplanets up into 4 distinct types: gas giants, Neptunians, super-Earths, and terrestrials. Which category a planet ends up in is mostly according to its size and mass, but other factors are taken into consideration as well. Gas giants, in general, are massive, unsurprisingly gaseous giants about the size of Jupiter or larger. But there are various more distinct subcategories too. Hot Jupiters, for instance, are particular types of gas giants found so close to their home star that, according to NASA, their temperatures soar into the thousands of degrees. Neptunian planets are of varying composition, but are usually around the size of Neptune. They have solid cores and atmospheres that consist of only the most basic elements, but again, there are variations. Many Neptunes are much like other Neptunian planets, except that they're much smaller. Next, super-Earths are planets found to be very like our own, but they're much more massive. And lastly, terrestrials are those smaller, rocky worlds, like Earth, where it's thought that there might be water, and therefore a greater potential for life. There have been some even more distinct planets identified as well. The Unified Astronomy Thesaurus, an open-source database for exoplanet information, has further categories including pulsar planets, extrasolar ice giants, free-floating planets, and chthonium planets, which are gas giants stripped of their atmosphere and outermost layers. Some of the strangest exoplanets ever discovered have included unique features like glass rain, sideways rain, coal-black surfaces, 100% lava surfaces, and even diamond cores. But there are patterns to be found too. For one, planets seem to have a preference when it comes to their overall size. There are very few that exist in the range of between 1.5 to 2 times the size of Earth. This apparent gap is called the radius valley, or the photon gap. And researchers think that it could exist because there's a critical size that determines how a planet evolves. If it grows large enough, then it quickly moves beyond the gap, gathers an atmosphere, and becomes a gas giant. But if it doesn't grow large enough, it never pushes through that gap at all, and remains on the other side of it. And what of the search for life? The number of confirmed exoplanets that are located within the habitable zone around their home star, with potentially perfect temperatures and Earth-like conditions, has mounted up and up. Using information gathered from these worlds, scientists can today better estimate the likelihood of alien life in the universe. An important measure on the Drake equation, for example, is how many habitable planets there are out there. And now, according to projections made following confirmed observations, it's thought that there could be as many as 300 million habitable planets at least, and in just the Milky Way. We're a long way from officially registering all of them, but the first steps, it seems, have been made. Moving forwards, the technology is always changing. The Kepler is no longer in service, but more planets are continually being discovered by still operational telescopes like the TESS, and researchers are also looking to new technology to help in the search, including the recently launched James Webb Space Telescope, which is capable of studying even the precise atmospheric conditions of these faraway worlds. For now, 5,000 officially discovered exoplanets and counting is certainly something to celebrate. But compared to the number that are estimated to be out there, with suggested hundreds of billions, perhaps trillions in the universe as a whole, the work has really only just begun. We still have many, many more to find, especially as most of what we've spotted so far have also been the planets that are closest to us in space, and often just a few hundred light years away. Each new planet registered, however, is another subject to study and to learn from, another new world to explore. It's been a long and exciting road to this point, but there's plenty more to come.
All the time, NASA is developing new technologies that will help us unravel the mysteries of the universe. Despite its uniformity, the cosmos remains an explosive and wildly unpredictable place, full of things we can't yet understand. But one day we will, and that's thanks to humanity's constant ingenuity. In December 2021, NASA launched the Imaging X-ray Polarimetry Explorer, a space observatory with a huge mandate to study some of the weirdest, most complex, and dangerous celestial bodies in the universe. Called the IXPE for short, the craft is one satellite of many that NASA has designed to study astrophysical phenomenon in the wider universe. In its sights, IXPE has everything from black holes to quasars to magnetars, truly the biggest, most powerful, and most dramatic objects that exist in outer space. IXPE can study them because it's able to image the X-rays that these objects produce, which other kinds of telescopes are incapable of seeing. Not only are X-rays invisible to other telescopes, they're invisible to humans as well. Our eyes can't see X-rays because they're beyond the visible light spectrum. IXPE is necessary over other more famous telescopes like James Webb, launched the same month, because it's an infrared telescope looking at the other end of the electromagnetic spectrum. The Hubble Space Telescope doesn't look at the X-ray region of the spectrum either. IXPE is, however, not the only X-ray telescope NASA has. It also has the Chandra X-ray Observatory, which has been in operation since 1999. But Chandra and IXPE aren't quite looking at the same things. Chandra is looking at the X-rays emitted by stellar mass black holes, among other things, while IXPE wants to examine active galactic nuclei, quasars, pulsars, supernova remnants, and more. By looking at the X-rays these objects produce, we're going to learn far more about them, potentially even about the center of our own galaxy, which remains mysterious. When it comes to the galactic center, we still have a lot to learn. We do know that there's a powerful radio source in the middle of the Milky Way, just like there is in the center of every other galaxy. In 2020, scientists finally proved that this radio source is a black hole. Called Sagittarius A star, it's estimated to be around 4 million times more massive than the Sun. And there are some theories that there could be multiple black holes hiding there, rather than just the one. In recent years, other X-ray telescopes, specifically Chandra, have made phenomenal discoveries about this region. The problem with studying the center is that there's so much gas and dust swirling around there that it completely obstructs our view. Chandra, however, can cut through the white noise and map powerful X-ray sources that would otherwise be totally hidden. IXPE is going to be able to do very similar things, seeing through gas clouds to pinpoint large radio sources and massive objects. It could finally show us exactly what's lurking in the center of the galaxy. And if we can study our own galactic center, this paves the way for studying other galactic centers that we can observe. Specifically, IXPE also wants to look at AGNs, or active galactic nuclei. An AGN is an exceptionally bright and compact region in the center of a galaxy, something that the Milky Way, which has an inactive galactic nucleus, lacks. The brightest AGNs of all are quasars, another dramatic object that IXPE has its eyes on. A quasar is a supermassive black hole with a gaseous accretion disk swirling around it. As this disk spirals down into the black hole, friction causes it to heat up, and it releases electromagnetic radiation. This energy is then emitted in the form of an astrophysical jet. A quasar with a jet pointing directly towards Earth is called a blazar. IXPE specifically wants to see exactly how these jets are produced in quasars and blazars. It's not just black holes that interest IXPE either. Already in early 2022, IXPE has sent back an image of a supernova that happened hundreds of years ago. This particular supernova remnant exploded in the 17th century and is called Cassiopeia A. And with the IXPE, we can finally see the residue that it left behind. The latest image of Cassiopeia mirrors one taken by Chandra in the 90s, but the new picture is even more striking. The massive explosion of a supernova is certainly one of the most dramatic and chaotic events to happen in the universe. And with every day that the IXPE mission continues, we're learning more and more about them, especially where X-rays are concerned. But what about other, far stranger types of stars? Magnetars are magnetically powerful neutron stars, themselves some of the brightest and densest objects in space, and IXPE wants to study them as well. Because magnetars have a strong magnetic field, they produce significantly more X-rays than other astronomical objects, which is why IXPE is perfectly suited to study them. Neutron stars alone are pretty weird and in need of further investigation, since they're the dead cores of giant stars that went supernova. They're also denser than even white dwarf stars. But the decay of the magnetic field of a magnetar is what produces these huge bursts of ionizing radiation, all of which are totally invisible to the human eye and to non-specialized equipment. Magnetars do all kinds of other strange things as well, including the emission of fast radio bursts, another cosmic phenomenon we're still studying. Similar to a magnetar is a pulsar, another type of very magnetic neutron star. It's unique because it creates huge beams of radiation, and to us here on Earth, it seems like it's pulsing. They're actually not pulsing, and are generally continually emitting these beams. But we can only see the beams when they're coming towards us from tens of thousands of light years away. Pulsars are so weird that when they were first discovered in the late 1960s, some people believed that they were an alien radio source thanks to the power and regularity of the signal. This regularity was just the rotation of the pulsar, and eventually we discovered so many that it became clear that they're not alien in origin at all. They really are just bizarre neutron stars, and we still know very little about them. One thing NASA hopes that IXPE will accomplish is discovering how exactly pulsars emit these concentrated bursts of X-ray energy. The more we can learn about pulsars, the better, because they could someday be used as interstellar lighthouses, provided we ever come up with a way to travel between stars. Pulsars also create something called pulsar wind nebulae. As we mentioned, neutron stars are the leftover cores of massive stars that went supernova. A pulsar is a neutron star that emits beams of electromagnetic radiation. A pulsar nebula emerges when the energy from a pulsar charges the remnants of the supernova that formed it. The nebula spread out far beyond the pulsar and continually emit radiation from across the electromagnetic spectrum. These nebulae don't just produce X-rays, but also infrared rays and gamma rays, becoming yet more potent energy sources in the universe. We know very little about pulsar winds beyond this, though older studies have tried to map the winds in 3D. Yet again, it was the Chandra X-ray Observatory leading these efforts, and the IXPE is going to continue them. One final mystery that the IXPE could unravel is that of X-ray binaries. These are binary star systems where the two stellar mass objects are innately intertwined. You could even describe it as a parasitic relationship. There's always a living star, but the other object could be another neutron star or a black hole. They generate a lot of energy, often in the form of X-rays, because the black hole pulls material from the star, creating a large accretion disk around itself, much like the disk that collects around a quasar. Some would even define these objects as microquasars. There are so many complicated and powerful objects existing out there in our own galaxy and beyond, and the Imaging X-ray Polarimetry Explorer is just the latest attempt of many to understand them.
So what do you think? Given all the work that's being put in, could NASA now be on the brink of a momentous discovery, of a history-defining announcement? It could be an alien city on a distant planet, or a breakthrough in our hopes for Mars. Is NASA about to find something really good in its search of deep space? Or perhaps something will crop up on one of the thousands of exoplanets that have been officially logged, or on the thousands more that are sure to be found in the future? Or do you predict something else will happen with NASA in the near future?